Question 3. A particle rests on a smooth horizontal table. It is connected to the ends of two horizontal elastic strings and the other end is being fixed onto two vertical walls. The left hand string has got natural length 1 and elastic constant 2. The other string has got a natural length 1 and elastic constant 4, and the two walls are 20 meters apart. We have to find the resultant force on the particle when it's midway between the walls and the position where the particle will be in equilibrium. Now, if the particle is positioned midway between the walls, that means it's 10 meters from the left hand wall and 10 meters from the right hand wall. So we've got two forces acting on this mass, the force to the left and the force to the right. Now, because the elastic constant on the right was greater than the elastic constant on the left, in this case the resultant force is going to be towards the right. So this resultant force F is going to be Fr minus Fl. So this means F is going to be K on L minus L0 for the elastic on the right minus K on L minus L0 for the elastic on the left. So the K value for the elastic on the right is 4. The length of the elastic on the right is 10 minus its natural length is 1. The K value for the elastic on the left is 2. The length of the elastic on the left is 10 also, and from that we need to subtract its natural length, which is 1 also. So this means F is going to be 36 minus 18. So this means the resultant force is going to be 18I because it's to the right. In part 2 then, we want to find the position where the particle will be in equilibrium. Now, if it's in equilibrium, the force to the left equals the force to the right. Now, we don't know exactly where this particle is going to be placed relative to the wall A, so we're going to let that distance be x. This means the remaining distance then would be 20 minus x. So the force to the left is going to equal the force to the right. So this means K on L minus L0 to the left is going to equal K on L minus L0 to the right. The elastic constant on the left is 2. The length of the elastic on the left is x minus its natural length is 1. And this is going to equal the elastic constant on the right is 4. The length of the elastic on the right is 20 minus x. And from that we're going to subtract its natural length, which is 1. So this means then 2x minus 2 is going to equal 76 minus 4x. If we bring all the x's to the left, you get 6x. All the constants to the right, you get 78. And then dividing, this means x is going to be 13 meters from the left hand wall.